Hello class, this lesson is about graphing exponential and logarithmic functions using relative extrema and points of inflection. So I left you with two packets. The packet you want to turn to is the one that says notes, and with all the lessons today, what I'm going to do is I'll do the example problems, and at the end of class I want you to practice on your packet. The next day, or I think maybe I'll post it on Twitter and also on Schoology. I'll also post the answers so you guys can see if you're on the right track. But you want to, every day, maybe choose two, choose three that you want to do, and follow along. And then what I'll do is I'll just check your packets the next day that I see you. So next Monday, I will check the packets, and not really checking for the correct answers, but just checking that you're practicing and practicing and practicing. There's no homework for the week, so what I want you to do is just try to follow along, and I have to do like a lesson a day so we can keep on pace for the AP exam. So you may notice, if you look at what we have to achieve in these in this section, they're all stuff that you've done before: increasing and decreasing, local extrema, concave up and concave down, and points of inflection. So all four of these we've done before. It's sort of a review for your AP exam. But the only difference is that I'm doing exponential and logarithmic functions. So I'm just going to add in the e's and stuff and see if you remember how to do this. Okay. So first off, it says increasing and decreasing intervals. And it also says what are the local extrema. So where are the mins and the maxes. So if I want to know increasing and decreasing and the mins and maxes, what I have to do is I have to take the first derivative. So I'm going to take the first derivative of this, f prime of x. And you'll notice if I'm taking the derivative of x e to the negative x, I'm going to have to do product rule, which is the derivative of the first one, which is just 1. Leave the second one alone. Plus, leave the first one alone. And then derivative of the second one, and you'll notice the derivative of the second one is going to be negative, or it's going to be e to the negative x, like itself, times the derivative of the inside, which is just negative 1. So hopefully y'all see, I can't check if you guys understand, but when I take a derivative of e to the negative x, it's going to be negative e to the negative x. Just to simplify it, it looks like this. Like so. Okay? And since I want to know where it's increasing and decreasing, what I'm going to do is I'm going to set this equal to 0. Because where it's increasing and decreasing and where the local extrema are, it's when the first derivative is equal to 0. So just a bit of a review. Hopefully you guys remember what to do from here, but I'm going to factor. They both, you may notice, have an e to the negative x, so I'll factor that out. And if I factor it out, I'm left with a 1, this minus, and this is left with an x right here. Now, if two things multiply to equal 0, so one of these have to equal 0, so either e to the negative x equals 0, or 1 minus x equals 0. So one of these has to equal 0. You could check on a calculator. You could graph this, but you'll notice that e to the negative x, it never equals 0. So there's no answer here. And 1 minus x equals 0, the answer here is 1. So on my number line, I will just put 1. And then, if you remember, I tested numbers to the left and to the right, and then see if it's positive and negative. So a good number to test that's to the left of 1 is 0, and a good number to test to the right of 1 is 2. Okay. I took these numbers, and if you remember, I plugged it into this factored first derivative, and see if I get a positive or negative number. Okay. If I plug in 0 here, this will become a 1. Plug in 0 here, this will become a 1. 1 times 1, or positive times a positive, which makes this whole zone positive. If I plug in 2, e to the negative 2, so you may think it's negative, but that just means the exact same thing as 1 over e squared, and that's a positive number. If I plug in 2 here, 1 minus 2 is a negative number. It's negative, which means this whole zone is negative. Okay. So just to make this quick, for letter A, to state the increasing and decreasing intervals, the increasing interval is from negative infinity to 1. And the decreasing interval is from 1 to positive infinity. So that's how you do letter A. Then letter B says state the x-coordinates of any local extrema. I only have one local extrema. The x-coordinate is 1, so this is letter B. And if I go from positive to negative, if my slope goes from positive to negative, if my slope is positive, also my slope turns negative, here I have a local max. And that's how you do that. C says state the concave up and concave down intervals. Okay, so you may remember to do concave up and concave down is the exact same process, but instead I'm going to do it with the second derivative. So remember, here's that first derivative right here. So I'm going to take the derivative of this. Derivative of this one right here, as we mentioned before, is negative e to negative x. I have minus, and you see I have xe to negative x again. It's exactly the same as the original problem, right? This part right here is the exact same thing as this. And we found that the derivative of this is this itself. So I know it's a little bit abstract, but when I take the derivative of this, it's negative e to negative x. And when I take the derivative of this, it's this whole thing again. So hopefully you guys see that when I take the derivative of e to the negative x, negative e to negative x, and when I take the derivative of this x e to negative x, it's this whole thing again. So that's why this drops here. And I have this minus and this minus right here. I'll simplify it. And I have two of these negative e to negative x's, so I'm just going to simplify it to negative 2 e to negative x minus x e to negative x. So now I'm done. I simplified all I can. Just like what we did, the second step is I'll set this equal to 0. Scroll down for you guys. And now, since it's set equal to 0, just like last time, I'll factor it out. You can tell which terms these have in common. And also, I'm going to take out this negative just to make things a little bit neater. So, I will take out a negative e to negative x. And you don't have to take out the negative. You'll get the same answer. That'll leave me with a 2 plus x. Now, I have two things multiplied to give me 0. I'm in the exact same, situation where this will never equal 0. So, no answer. And this will equal 0 at negative 2. Hopefully you follow along. Then I drew my number line, and the only number I have is negative 2. The easiest numbers to test to the left and the right of negative 2, negative 3, and 0. And I will test these numbers and plug them in and see if I get a positive or negative number. If I plug in a negative 3 here, okay, this negative e to negative x means the exact same thing as negative 1 over e to the x. Okay. If I plug in this negative 3 here, basically flips it. Make a long story short, you always have this negative out here. This one always will be negative. If I plug in a negative 3 here, I'm going to get a negative number, which means this whole zone is positive. Negative times negative is a positive. If I plug in 0, e to 0 is 1, 1 over 1, and I still have this negative out in front. Plug in 0 here, 2 plus 0 is positive, which means this whole zone is negative. So going back to the original question, where's this concave up and concave down? It is concave up here where it's positive. And it's concave down over here where it's negative. And then where it says, where are my points of inflection? State the x-coordinates of any points of inflection. In this case, I don't have to say if it's a max or min. I just want the point of inflection. Well, the point of inflection is right here. So this is a little bit of a review. I think you guys remember it or understand it. Let's try another example. Same 4 questions, but with a new problem. I need to take the derivative of this. Okay. You'll notice that I have a division of x and ln x, so I have to use quotient rule. It's been a while, but we'll practice it. All right. Sorry. Okay. I will take the derivative of the first one, which is 1, leave the denominator alone, minus, leave the numerator alone, and the derivative of the second one, and the derivative of ln of x is 1 over x, all over the denominator squared. Okay, so far? Then I will simplify this. I get ln x minus 1 over ln x squared. And you'll see that, x times 1 over x, that just becomes 1. Okay. Then to simplify this, what I'm going to do is I'm going to distribute this ln x to both sides. This means the exact same thing as so you see I just distributed this ln x to both sides. Here I have an ln x at the top. I have 2 of them on the bottom, so that can just cancel out to just 1 over ln x. And this one, I have 1 and then 2 on the bottom. I can't simplify it, but I just have to leave it like. So, make sense? Okay. There's nothing else I could simplify. Okay, nothing else I could do. So this might be where some of you get lost. But here, I have this ln x squared. One of the rules for logarithms, and it might be a while or you might have seen it, but if I have something, actually no, this is perfectly fine. Haha, just kidding. So what I have now is a simplified version of that, and what I'm going to do is I'll set it equal to 0. Next thing I had to do was factor. You may notice that both of them have a 1 over ln x. So I'll factor that out. Just leaves me with a 1 minus. And here, if I take out a 1 ln x, I'm going to, there's 2 of them here, so if I factor it out, I'm going to get just left with 1 ln x, like so, equal to 0. Make sense so far? So now we're stuck with, when in these 2 instances, does this equal 0? So I'm running out of space, so I'll use up here. So either 1 over ln x equals 0, or 1 minus 1 over ln x equals 0. In this fraction, and it might be a little bit more difficult for you to comprehend, no matter what number this is, like even if this was just, if this ln x was gone, if it was just 5, or infinity, or 1,000, or a million, or -3, can you imagine that there's no number in the denominator? There's no number that this denominator could be that would make this equal to 0, right? There's no, I can't think of any number that would go here that would make this fraction equal to 0. So just like the last problem, there is no number that would make this equal to 0. Okay. This one, it might be a little bit more complicated. So what I'll do is I could do what we used to do in Algebra 1. I'll move this over. So 1 equals 1 over ln x, right? I could flip both sides, or I could flip this side and flip this side. If I flip 1, or if I flip 1 over 1, that's still 1. And if I flip this side, I get ln x over 1, or just ln x. Or another way to think of it, I'm trying to think about when is this denominator equal to 1, because if this denominator is 1, then this whole fraction is equal to this. Or another way to think of this, if this whole fraction is equal to 1, 1 minus 1 equals 0. So my goal is, when does this denominator ever equal 1? Because if it does, 1 minus 1 equals 0. Okay. So when is 1, or what does x have to be for this to be equal 1? A little bit abstract, you may have forgotten, but when x is e, that is when it is equal to 1. And then you can use a calculator, you may have forgot how to do it, but it's when you take the ln of e, or they're inverse of each other, that's when I get it equal to 1. So my only extrema is e. I'll put that on a number line. I need to test two numbers. Remember, e, it's like pi. It's a rational number. It's 2.6-ish. So the easiest number to the left of e, I think, is 0. And the easiest number to the right of e is 3. Sorry, it's supposed to be a 0. If I plug in 0 here, okay, this isn't going to work. Well, because 0 is undefined here. Let's try 1. Okay. That won't work either, because ln of 1 is 0. Again. Let's try 2. Okay. ln of 2 is a positive number. Okay. 1 over L, and you can put that in a calculator, and 1 over ln of 2 is positive. Okay. Let's do this. Let me pull up a calculator so you guys can see what I'm talking about. There you go. Here's my calculator. And then I have 1 minus ln x, so let's do ln of 2 is this. And I'll just simplify it to 0.69. 1 divided by 0.69. So this is 1.44. 1 minus a 1.44, you'll know that's a negative. So that means this whole side right here is negative. 3, if I plug in a 3 here, same thing, ln of 3 is a positive number. 1 over ln 3, that's going to be positive. And let's plug in the ln 3 here. I'll pull up the calculator again. And if just to prove it, let's do ln of 3. See how that's how it is. So 1 over ln of 3, it's still positive. That's how I got that positive. Oops. Shouldn't have put that circle there. Positive. And then I'll do ln of 3 here. Oops. ln of 3. I want 1 over it. And I'll round this up to like 1.1. 1 over 1.1. 0.9. So 1 minus like a 0.9. Can you tell it's a positive number? So this is a positive, that's a positive. The whole thing is positive. Okay. Negative time, sorry, this is negative, this is positive. So the answer, letter A, the part that's increasing is from e to infinity. That's increasing. And decreasing is everything to the left here, which is going to be everything from negative infinity to e. And then B says, where is my local extrema? Obviously, it's at E. And then I go from a slope that's negative to a slope that's positive. So you notice that at E, I have a local min. And just for sake of time, I'll stop it there. So what you're going to do is you're going to turn to your packets, the front of your packets, and I want you to try out, in this case, maybe you just want to try out 1 or 2. What I'm going to do is I'm going to open up a discussion board on Schoology, and by doing so, and it'll just be for the whole week, like questions for the week, and I guess like instead of saying that you have homework, but what I want you to do is put some questions or things you don't understand or something that you tried in class, and in this case, even though we had the Benny rule, maybe if you want to put that you have no questions, and that way I could just know that you're logging on, and I could just keep a running journal of how you did. I'll put more instructions on Schoology. So keep that in mind. Also follow on Twitter. If you guys have a Twitter. No, you don't have to have a Twitter. But it's easier. And that's what we're going to do for the rest of the week. So every week, 1 video, 1 worksheet, and that's what we'll keep on doing. So thanks for listening, and hopefully enjoy your day.